Today's lab we're going to do a steam distillation, and just wanted to show you pieces of equipment that you'll need to set up the apparatus. Some of this glassware looks a little dirty, so just make sure that you always clean the glassware before you actually use it, and always, as a reminder, clean it after you're done using it. So we're going to need a 100 milliliter round bottom flask. We have a Claisen adapter. The Claisen adapter will be connected to the round bottom flask. The steel head will be connected to the Claisen adapter. We do have two stoppers. We are not using a thermometer in this particular lab, so the top of the steel head and one of the side arms of the Claisen adapter will be a stopper. And then we're going to have a condensing column. Obviously, we always want to have some type of stirring mechanism. I'm going to use a stir bar today. We have our vacuum adapter, and then we have a receiving flask. The goal today is, from the mixture we're distilling, is to distill about 30 milliliters of the mixture, and I would use most likely a 50 milliliter round bottom flask for that. Also, we've seen before using the blue clips here. Our heating source again is going to be a heating mantle, Variac. Since we are using a condenser, we do need the rubber tubing, and probably need about 3 clamps as well. And then we've always said before that anytime you're using this ground glass joints, always make sure you use a silicone grease to grease those before you hook everything together. The mixture that we're going to use today for the steam distillation is lemongrass oil. So I've got 2.5 milliliters of the lemongrass oil, and we need the weight of this, so I went ahead and weighed what the 2.5 milliliters of lemongrass is, and that is 2.278 grams. So we have 2.278 grams of lemongrass oil, which equals the 2.5 mils. I'm going to pour that into our 100 milliliter round bottom flask. This is going to be our distilling flask. It is equipped with the magnetic stir bar inside. To that, we're going to add 60 mils of distilled water. Once I have everything set up, I'm going to talk about what steam distillation is, when can you use it, and what the purpose of that is. The first thing that attaches to the distilling flask is the Claisen adapter. And I'm just going to go ahead and put some grease on these joints. And it's a good idea just to go ahead and rotate that a little bit, just to make sure that you've got a pretty good seal. The steel head is going to attach to the top of this Claisen adapter. Typically we put a thermometer adapter into the steel head. The temperature of the boiling mixture, what co-distills over, typically does not go above 100 degrees Celsius, so therefore there's really no need to use a thermometer. However, what we need to do is to use these glass stoppers. Again, these glass stoppers are designed to fit these glass joints, and so we certainly need to put those in, rotate that around just so we have a good seal. And I'm not using very much of the grease, just enough to kind of coat it. A little of the silicone grease goes a long way. I'm going to put the condenser, connect that to the steel head. I think at this point it would be good to use the clips here, just to kind of keep that attached. We're going to put a vacuum adapter. I've already greased this end, so our vacuum adapter. And the vacuum adapter, I'm going to grease the bottom of it. It's ground joist fitting. And we will attach the receiving flask, which I'm going to go ahead and clamp. Sometimes when you shift things to get the clamp on, I'm not sure if you notice that, but things become, even with the clip on, become strained or loosened. So I'm just going back. I want to make sure that all of these fittings are tight. I don't want any vapors to be expelled into the atmosphere. I want everything to be contained. We could put another clip here just to keep that in place. I typically don't like to put clamps around stoppers. Theory behind that, if pressure was to build up, I'd rather for this to pop off than something else to blow. And I may raise this up just a little bit. We don't want any of this to be leaning or tilted, but I think that looks pretty good. We're going to add, I think the 2 clamps here is enough. I don't see the need of, you could put another clamp here, but I think what we have here should be sufficient. We need to add the water tubes. Just making slight changes or variations. Just want to make I'm not using the hot plate as a heating source, and the tubing is not touching the hot plate, but just FYI also, if you are using the hot plate to heat something and you're using these rubber tubings, you don't want them to melt when they come in contact with the hot plate. It's not touching it, but again, I'm not using the hot plate for a heating source. So one last check. Everything looks good. So I'm going to turn the water on, and really don't need quite that much, but be careful when you are turning the water valve on, because, and that looks pretty good as a flow coming out. Be careful when you are turning the valve on for the water, because it is possible that it takes a while for the pressure to adjust, and it could come out pretty quickly, so just be careful for that. So we've got our system set up, we've got our heating mantle, we've got our lemongrass oil, the water, we've got everything hooked up, so the next step is just to heat it. Before I start heating it, let me just say a little bit about steam distillation to start with. So we've already talked about simple distillation, and simple distillation was a method we could use to separate a volatile substance from a non-volatile substance. The fractional distillation is a way that we could separate 2 liquids from each other from differences based on their boiling points, and to separate them the most pure method possible, we used a fractionating column that would allow separation of those 2 substances, again based on their differences in boiling points. There are some substances that have a fairly high boiling point that if you try to use maybe fractional distillation or some other method, that when you heat them up close to their boiling point, they actually decompose. And that's where steam distillation can be of value to you. So in terms of steam distillation, you can separate if a substance is volatile, and if it is immiscible in water or fairly immiscible in water, you can use steam distillation, or may be able to use steam distillation. So what we have here, the reason we're adding the water, and if it's called steam distillation, we need a source of steam. So there's several ways that you could add water to the system. I'm using it where it's an internal source of steam. I added water directly to my sample. It is possible that to the left of this Claisen adapter, I could have a flask of boiling water with a outlet tube that would go into the Claisen adapter and provide steam that way. We call that an external steam source. For this particular lab, I think the internal steam is sufficient enough to isolate the sample that we're trying to isolate. Well, this is lemongrass oil, and the sample or the compound or components that we're trying to remove from the lemongrass oil is citral. And citral is a 8-carbon aldehyde that has 2 double bonds within the structure. There's usually 2 isomers present. There's one isomer that is the cis form and the other one is the trans form, and when we do this steam distillation, we will collect both of those. Our purpose today is not to separate the isomers from each other. Our purpose today is to separate the citral, this 8-carbon aldehyde that has double bonds within its structure, from the lemongrass oil. So when I turn this on and start heating it, and this starts to boil, then mostly of what's going to go over is the water. We have a co-distillation, if you will, that the citral that is inside the lemongrass oil will co-distill with the water. The thing is that water has the lower boiling point, so I'm going to collect much more water than I would the citral. When we start boiling this, the water vapor, the water molecules will vaporize, they'll move up here, but the only substance that can adhere to the water is not dissolving in the water, but it is possible for some of those citral molecules to vaporize because it is volatile. It can vaporize and be distilled with the water. So we're going to turn this on, but this is going to start boiling. We want to heat it not terribly high, but we want the distillation to continue fairly rapidly. So I'm going to turn it up somewhat high, not to the highest level. We want this to boil and we want that to carry over. When we look at the receiving flask, we're trying to get as much of the citral to distill over. There's a couple ways to look at this. Typically with this amount, if we collect about 30 milliliters of material here, we probably have most of the citral carried over. It is possible that another way to look at that, if you're not seeing any additional oil carry over into the receiving flask, that's another way to tell that the co-distillation is complete. So I'm going to go ahead and turn this on. And I may, once it does start boiling, I may go ahead and put some foil paper, aluminum foil here. We did that with the fractional distillation on the fractionating column. Since this is being carried out, this experiment is being carried out under the fume hood, this has its own cooling mechanism, if you will, so I don't want this to cool down very much. So I'll probably wrap this portion in foil just to keep this hot when it does, the steam does come up here with the citral that's being carried over. Turn the stir bar on. And then, as we've seen with the other distillations, it's just a matter of waiting. I just wanted to give you a look at what is happening inside the Claisen adapter and also the still head. I covered this up with foil just to make this as insulated as possible so that we would get better yield as far as the co-distillation is concerned. So as you can see, and I just kind of want to re-emphasize this, the reason that this works, even though that the citral has a very high boiling point compared to a lot of other organic chemicals, around 229, it is volatile. So when the water goes into the vapor phase, it is also possible that the citral will also do the same thing, and it can be carried with the water through this co-distillation process. We typically keep doing this, collecting the distillate until we have about 30 mils of material over here, most of which is water, because obviously we have a lot more water over here than we do the citral that's inside the lemongrass oil. The other thing is, it is maybe hard to see, but there is a thin layer. The citral is on top of the aqueous layer, and we're going to separate these two in the next step. But just want to give you an idea of what it looks like in terms of the steam, and you can see how the water and the citral is distilling over. The lemongrass oil itself is going to stay behind. It's not volatile, so it will stay behind. The only thing that's coming over would be the citral, which again is a mixture of two isomers, and the water that's coming. But you can see how this will rise up, condense back down, rise up, some of the vapors, and you can even see the same thing here. Not everything that vaporizes is going to go through the condenser. You can see some of that condensing back down into the still pot here. Just another piece of information about the citral. I have read that citral has been looked at in terms of having some type of anti-cancer properties against breast cancer, has some type of anti-pyretic properties, and has been used in combination of reacting with other substances to have certain other medicinal properties. So it does have quite a usage, if you will. I'm going to let this go maybe just another minute or so. I'm kind of looking here also. I've not seen a lot more droplets of the oil. Sometimes you can kind of see those separate. So I'm going to go ahead and cut this part off here. And then I'm going to let this cool. And then once this cools, then we're going to take this mixture, which is water and the citral, and we're going to do a type of extraction where we add another component to this mixture, and the citral will dissolve in that other organic substance, and we will be able to separate that from the aqueous layer.